Next we will have a look at static routes, which is in routing. Static routes, so you can add static routes from here. Click add, choose the interface. The network can be reached through from here. Specify the destination network here, or pick an object. You may already have one created, and choose the next hop IP address here. You can create that from here, or you can pick one from here, or you can create a new one by clicking add here. And you've only got host because it's a gateway IP address. It's a next hop IP address, where on the network side you'd have the option of host or network here. And then the next bit is the metrics. So you don't have to configure this. This is only used so metric, if you have two or more routes for the same destination network, then you can specify the metric here, and the low metric wins. So by default the metric is 1, and you may want to change if you have two different routes to the same destination network. So this is a measure used by routing protocols to calculate the best path to a given destination. So if you make the metrics the same, however, then it should be able to load balance the traffic. So you can find more information on this by looking at equal cost load balancing. And then we've got some further options down here. So you've got none, so you don't have to pick any of these options. These are just additional options. You've got tunneled, specifies the route as the default tunnel gateway for VPN traffic. So use this option for the default route only for VPN traffic. And then you've got tracked, and this is another name for SLA monitoring, where you can track the availability of a static route. It allows the Cisco ASA to remove static routes from its routing table if it thinks that the route is not available. So it's a good monitoring, tracking method of looking at routes and being able to detect if one of them cannot be reached. So you've got some further options in here, such as track ID, enter unique identifier for the route tracking process from here. You can specify enter the IP address or host name of the target being tracked. So typically this would be the IP address of the next hop gateway for the route, but it could be any network object available off that interface. So you've got the SLA ID next, so enter unique identifier for the SLA monitoring process. The valid values are from 1 to 2 billion or something. Target interface, so you'd specify the target interface you would like to track through. The target interface is the interface through which you'll be polling the destination IP address to determine if the route through that interface is still valid. And then you've got some further monitoring options here, so it gives you some further advanced settings like the frequency of ICMP checks, etc. Okay, let's have a look at DHCP settings next. So that is configured in device management and the DHCP option here. So you've got two options. We're not looking at DHCP relay, but DHCP relay passes DHCP requests received on one interface to an external DHCP server located behind a different interface. We're just having a look at the DHCP server, and you can enable DHCP server on a particular interface. So typically the DHCP function on this ASA is used in small networks where there isn't a DHCP server deploy, like Microsoft DHCP or Infoblox. You can make the Cisco ASA DHCP server in which it will lease out IP addresses to hosts. So we can edit that from here. We'd pick an interface we'd like to be the DHCP server, off the DHCP server. So we can enable the DHCP server with this tick box here. We'd specify the start and end IP addresses here for your DHCP pool. Next we can specify the DNS and the Win server IP addresses here. So this is to be able to resolve names to IP addresses. Give it a domain name from here. So enter valid DNS domain name of your company, example.com, cisco.com or something, whatever the name is of your company. The next part is the ping timeout. So you'd enter the parameters for the ping timeout values in milliseconds in here. So this is so to avoid address conflicts, the security appliance sends 2 ICMP ping packets to an address before assigning that address to a DHCP client to ensure that address is not already taken, basically. And then next you've got your least length. So you'd enter the amount of time that the client can use its least IP address before it expires. And default value is 3600 seconds, which is 1 hour. But you can change that from here. And then you've got this next option, which is enable auto configure from interface. So you can configure this stuff from another interface. It pulls it from a client that's already using these parameters. So you check this box to enable this configuration, and you'd select the interface from the menu here. You'd click that, and then you can select the interface from here. So this causes the DHCP server to provide DHCP clients with DNS server, domain name, and WIN server information obtained from a DHCP client running on the specified interface you click on here. So if any of this information obtained through auto configuration is also specified manually here, the manual parameters take precedence over this setting here. So this is like a backup to this. So if it's missing any information, that this will be able to pull that information from a client on the specified interfaces. Advanced options. So in advanced options, you can specify additional option parameters you can allocate via DHCP to clients. For example, let's just say static routes. So you can assign option 33 static routes via DHCP to clients, or something else such as NTP. So you may want to specify what NTP servers you want your clients to sync with. So you can sort of choose that and add your NTP servers here. And then you've got your dynamic DNS settings here. So in this section you can configure the DDNS update settings for the DHCP server. So DDNS is useful when the firewall IP address changes and when it becomes when it obtains a new IP address lease, where it will dynamically associate the host name with the new IP address, so you don't have to manually do this, and you'd enable it from here. So you can update both records. So you check this checkbox to specify the DHCP server should update both the A record and PTR record. So I suggest you look at DNS and what A records are, PTR records, etc. Override client settings. So you can check this box to specify that the DHCP server actions should override any update actions requested by the DHCP client, and that's it for dynamic DDNS on here. Next we'll have a look at address translations. So if we go to firewall, got some Nat rules here. So you can configure a basic Nat rule, so we can use Nat to ensure users on the local network can get out to the internet by ensuring they are represented by a public IP address, so traffic can be routed back to them. So you can configure Nat via address objects, or you can configure it in here. You can add it here, add a network object Nat rules, or you can go to objects. Let's say you're configuring your local network, so add a network object, give it a name, local users. So it'll be a network, give it a network IP address 192.168.65.0.1, net mask 255.255.255.0. That's network address should be .0. So then you can do your NAT from here. So what you do here is you add automatic address translation rule from here, and then you pick the NAT type. So the one that we need is dynamic port address translation. So with this option you can specify a single public IP address which uses many different source ports to ensure every connection is unique. So PAT translates multiple real IP addresses to a single mapped IP address by translating the real address and the source port to the mapped address and a unique port. So that's it. And if we go to the actual address, we can pick address, a public address, for example 1.1.1.1. Click OK here. Also in advanced options you can specify the interfaces, the source and destination interfaces. So let's say from inside our Intel network to the outside world, to the internet or something. And click OK here. So if we click OK on that, we've got our object here. But if we have a look in Nat Rules, we'll see it at the bottom here. So from inside, if you can see at the top here, match criteria, original packets, actions, translated packets. So from inside to outside, the source is the local users. Everything else is the same apart from here. So it's going to be port address translated to this public address 1.1.1.1. So we've got our Nat Rule in place now. If we go to device management, management access, and we have a look at this section here. So we're able to, so you can specify your admin spaces and the IP address from which admins are allowed to connect from. You've got two here already in place. You can click on add here, and you can specify your access type, so ASDM, HTTPS, Telnet or SSH. So we can click that, click which interface you're allowing access through, management interface for example, or let's go for inside. Give it an IP address, the source IP address and subnet mask you are permitting access from. So, and then just click OK here, and that's done. Yeah, so and then you've got some further options here. So enable HTTP server. You need to keep this checked to access HTTP server and use ASDM and HTTP. Then there's a lot of timeout sessions down here, and the default is 5 minutes for these. Next we'll have a look at system images and auto updates. So you can do that from system image configuration auto updates. So to enable communication between the ASA appliance and an auto update server for updates of the ASA configuration as well as software images, you'd have to configure this area here. So you'd specify the server URL by clicking add here, giving it a server URL here, choosing HTTP or HTTPS from here. You'd verify the SL certificate to confirm that an SL certificate is enabled on the auto update server. You'd enable this checkbox. User, you'd give it the username and password to allow you to log into the auto update server, and that's it. So you've got your polling, so you can specify the polling intervals for the updates here. Timeout period, so if it's not if it's not connecting to it, it will time out at a particular period if that's what you wanted to configure. Device ID, you can enable authentication using device ID. So the device ID is used for to uniquely identify the security appliance to the auto update server. So then you can specify the type of ID to use, and you've got the different options of type of IDs here to use. And that's it for the basic settings of the Cisco ASA appliance. Thanks for watching.